In a certain group of 15 students, 5 have graphics calculators and 3 have a computer at home. One student has both. We can see that student just here. So graphics calculator is G, computer at home is an H. 2 of the students drive themselves to college each day. So that's these 2 here. Neither of them has a graphics calculator nor a computer at home. So we want to determine G and H, the probability of G and H. So let's have a look. Altogether we know that there are 15 students. We're told this just here. So the probability of G and H is just going to be the number of things in G and H, which is 1, divided by the number of students, which is 15. Now we want the probability of H given G. So the situation now is that we know that G has occurred. So there's only 5 students we could be choosing from, and that's the denominator. For H to have occurred, it must be this one student, so that's going to be 1/5. In part C, we have the probability of H given not G. So if we're given not G, I'm going to shade G again because it's easier, but now we're going to consider everything that isn't shaded outside of G is what must have happened. So we've got in all 10 students out there, and we want H to have occurred, so that's these 2 students, so that's going to be 1/5. And finally, we want the probability of G given not D. So not D, what I'm going to do is I'm actually going to shade D, and we'll consider everything that isn't shaded. So that involves 13 students. G to have occurred is these 5 students, so that's 5/13.